Now in the upcoming tutorials, they'll demonstrate how to create and modify alignments. You begin creating an alignment by making the location of tangents and points of intersections for the road centerline alignment. During the creation process, curves between tangents can be created automatically or added later. To accommodate high-speed travel, spirals, and superelevation can be added to the curves. You can enter numeric parameter values for lines, curves, and spirals in the Alignment Entities table. If your alignment design must meet minimum standards, you can apply design criteria to the alignment either before or after it's created. The upcoming tutorials will demonstrate basic alignment creation tasks. In this exercise, you'll use the alignment layout tools to draw an alignment that has curves. So first of all, go ahead and open up your Align-1 drawing in your tutorials folder. Now this drawing contains a surface that has several circles that are labeled A to D. Now ensure that your OSNAP is on by clicking this button right here. Go ahead and go to your Home tab and to your Create Design panel. Click the Alignment drop-down, then click Alignment Creation Tools. We'll get the Create Alignment Layout dialog box. Let's start by naming our alignment. Type in First Street. Now under the General tab, select the following settings. For Site, we're going to keep it at None. For Alignment Style, we're going to leave it at Layout. The current alignment layer is correct, and the alignment label set is correct. Now note that setting the site to None prevents the alignment from interacting with other objects in the drawing. The None selection is helpful when you don't want parcels to be created when either intersecting alignments form closed regions or the alignment crosses an existing parcel. Go ahead and click the Design Criteria tab. The starting design speed value specifies the default design speed at the alignment starting station. Design speeds can be later specified on other stations along the alignment. If no other design speeds are specified, the starting speed is applied to the entire alignment. We're going to accept the default starting design speed value for this exercise. Now the other options on this tab are used only if you want to ensure the alignment design meets specified design criteria. Do not apply design criteria to the alignment in this exercise. You'll learn how to use the design criteria feature in another exercise. Go ahead and click OK. Now the Alignment Layout Tools toolbar is displayed. It includes the controls required to create and edit alignments. In the Alignment Layout Tools toolbar, go ahead and click this drop down right here. Select Curve and Spiral Settings. Now in the Curve and Spiral Settings dialog box, you can specify the type of curve to be automatically placed at every point of intersection between tangents. Now in the Curve and Spiral Settings dialog box, specify the following parameters. We'll leave the type at its default. The Spiral In checkbox, we're going to leave that cleared. Curve, we're going to leave it at selected. But for the default radius, let's change that to 350. And we're going to leave the Spiral Out checkbox cleared. Click OK. Now under your layout tools, go ahead and click that drop down again. Select Tangent to Tangent with Curves. Snap to the center of circle A. Go ahead and stretch the line out to B, then continue until you get to D. And go ahead and right click to end the command. Go ahead and pan and zoom to review the style. You can see all of the stations are on their own layer. We can see our tangency, and it looks very, very nice. Now as you're examining your alignment, note the geometry points for the start and the end of each line, spiral, and curve. So that's how you go about creating an alignment with the Alignment Layouts Tools toolbar in Civil 3D. In this exercise, you'll add a free curve and a free spiral curve spiral to a simple alignment. The drawing contains a simple alignment, as you can see here, consisting of 3 tangents. In the next few steps, you'll add free curves at circles B and C. This exercise continues from the previous exercise where we created an alignment from the Alignment Layout Tools toolbar. Go ahead and open up the Align-2 drawing in your Tutorials folder. Now set your drawing window so that you can see both circles B and C on the surface. If the Alignment Layout Tools toolbar is not open, select the alignment, right-click, and select Edit Alignment Geometry. In the toolbar, go ahead and select this drop-down menu, and then select Free Curve Fillet between 2 entities using a radius. Now the command line is asking us to select the first entity. Go ahead and select the tangent that enters into circle B. Then select the tangent that exits from circle B. Press Enter to select the default value of a curve less than 180 degrees. Now enter a radius value of 200. Now you can see the curve is drawn between the 2 tangents as specified. Go ahead and exit out of your command and zoom into circle C. Now select this drop-down menu and select Free Spiral Curve Spiral between 2 entities. It's asking us for our first entity. Select the tangent that enters into circle C. Then pick the tangent that exits circle C. Go ahead and press Enter to select the default value of a curve less than 180 degrees. And then enter a radius value of 200. Enter a spiral in length of 50. And then enter a spiral out length of 50. Now notice the default values that are shown on the command line. As you can see right here, go ahead and exit the layout command by right-clicking in the drawing area. I'll go ahead and zoom out. And as you can see, this is how we go about adding free curves and spirals to an alignment in Civil 3D. In this exercise, you'll add 2 floating curve entities to a simple alignment. First, you'll add a best fit floating curve that follows the most likely path through a series of points. Then you'll add a floating reverse curve with spirals. Now the drawing shows a simple alignment consisting of 3 tangents with curves. In the next few steps, you'll add 2 floating curves to the end of the alignment. This exercise continues from our last exercise where we went about adding free curves and spirals to an alignment. Now note that this exercise uses the Align-2 drawing with the modifications you made in the previous exercise. Or you can open the Alignment 3 drawing from the Tutorials folder. Now go ahead and pan and zoom until you see circles D and E on the surface. On the Home tab, go ahead and go into your Layer Management. And then turn on your C-Points layer. Now you'll see a group of points are displayed. You'll use these points as a basis for creating a floating curve that follows the most likely path through these points. Now note that if these points do not appear, go ahead and type in regen on the command line. We'll do that right now. Now if the Alignment Layout Tools toolbar isn't open, select the alignment. Now remember that we can right click on the alignment and click Edit Alignment Geometry. We get our toolbar. Now select this drop-down menu. Pick the floating curve Best Fit. Then you're prompted on the command line to select the entity to attach to. Go ahead and select the tangent that ends in circle D. Then in the Curve by Best Fit dialog box, make sure that the Kogo points is selected. So we have that selected right here. Go ahead and click OK. Now the command line prompts you to select point objects or numbers and groups. Go ahead and enter in G for groups. Now in the Point Groups dialog box, select all points, then click OK. The Regression Data Vista displays information about each of the points that are included in the regression analysis. Let's move this off to the side a little bit. Now the drawing displays a red dashed line indicating the path of the best fit curve. An X marks the location of each regression data point. Let's open the regression data up just a little bit more. Now note the point numbers in the point number column right here are sequentially generated as regression data points are added or removed. They do not correspond to the actual Autodesk Civil 3D point numbers. Now you'll modify some of the regression data to better suit your design. In the Regression Data Vista, go ahead and browse to point 16. Select the Pass Through checkbox. Selecting this checkbox specifies that if the curve does not deviate from the regression data, it will always pass through point 16. Now go ahead and click the checkbox to create the best fit floating curve. The Regression Data Vista closes and the regression point markers disappear. Now in the drawing, select your alignment. Click the cyan grip at point 16, which is the end of the floating curve. Drag it towards one of the other points. Click to place the grip at its new location. In the toolbar, click Edit Best Fit Data for all entities. Now notice that the original regression data is replaced in the Regression Data Vista, and the original best fit curve is displayed in the drawing. The shield icon up at the top here indicates that the alignment layout does not comply with the regression data. When you move the grip at point 16, you move the pass-through point from the location you specified earlier. Click the shield to synchronize. Check to close the vista. Now you can see that the entity returns to its original location. Go to your Home tab and then into your Layer Management, and then turn off your C-Points layer. On your Layout toolbar, click this drop-down. Select the Floating Reverse Curve with Spirals from Curve, Radius, Through Point. Our command line says Select Curve to Attach to. Select the curve entity that ends in circle E. Enter a spiral length of 75, a radius of 200, and a spiral out length of 75. Now, specify a pass-through point through the center of F. The reverse curve with spirals appears. Exit the layout command by right-clicking in the drawing. Now you know how to go about adding floating curves to an alignment in Civil 3D. In this exercise, you'll use the Alignment Entities Vista and Alignment Layout Parameters dialog box to edit the layout parameter values of an alignment. This exercise continues from the Creating Alignments tutorial. Note, ensure the dynamic input is turned on. The way you go about doing that is just type in DYN and make sure it's set to 1, which it currently is, so press enter. This drawing uses the Align-4 drawing in your Tutorials folder. The drawing contains a surface marked with several circles, as you can see here, labeled A through F. Note, ensure that Object Snap or OSnap is turned on. You do that by clicking on this button right here. If the Alignment Layout Tools toolbar isn't open, go ahead and select your alignment. Then, in the Modify panel, click on Geometry Editor. On the Alignment Layout Tools toolbar, click the Alignment Grid View. You can go ahead and examine the Alignment Entities table in Panorama. In the first column, you'll see that the alignment segments are numbered in the order in which they're solved. Each row of the table shows useful design data about a specific entity. Each curve group has a two-part entity number and a separate table row for each spiral and curve. Values shown in black can be edited. Note, to make other parameters available for edit, you can change the tangency constraint by clicking on it, and you get a drop-down window. Or you can change the parameter constraint. Just click this little lock icon. On the Alignment Layout Tools toolbar, click the Sub-Entity Editor. Now, as you can see right here, the Layout Parameters window is displayed, but it contains no data. Go ahead and select the Grid View button again, and then select any row for segment number 4, which is the Free Spiral Curve Spiral entity in Circle C in your drawing window. The design data for all 3 of these sub-entities is displayed in a 2-column table in the Alignment Layout Parameters window, where the data is easy to review and edit. If your design requires precise values for minimum curve radius, length, or spiral A values, you can use the Alignment Layout Parameters window to enter the values. In this window, let's go ahead and change the length value for a spiral to a higher number, such as 100. Note how this immediately increases the spiral length in 3 locations, in both the Alignment Layout Parameters window and in the Alignment Entities table. If we close all of this out, numeric values change and the geometry points move along with their station values, and the length of the spiral itself changes. Let's go about displaying a range of sub-entities in the Alignment Entities vista. In the drawing, control-click the curve entity for Circle B. The Alignment Entities vista displays only the attributes for the curve entity. In the drawing, control-click the Spiral Curve Spiral entity in Circle C. Notice that the Alignment Entities vista now displays the attributes for each of the entities you selected, plus the tangent between them. To display the parameters of another entity in the Alignment Layout Parameters dialog box, press Escape to display all alignment entities on the Alignment Entities vista. So that's how you go about editing the layout parameter values of an alignment in Civil 3D. In this exercise, you'll use grips to move alignment curves. In future lessons, you'll learn how to grip edit offset and curb return alignments in the Working with Alignment and Curb Return Alignments tutorial. Note, to change the behavior of an entity, you can change the tangency constraint and parameter constraint value. This exercise continues from editing the layout parameter values of an alignment. Note, ensure that the dynamic input is turned on. You can do that by typing in DYN and make sure it's set to 1. And make sure that the OSnap is turned off. which is this icon right here. This is the on position, and this is the off position. Let's go ahead and grip edit a free curve entity. Note this exercise uses the Align-4 drawing with the modifications you made from the previous exercise. Zoom in to Circle B. Click the alignment, and grips appear at the curve ends, midpoint, and at the point of intersection, or PI. Go ahead and click the midpoint grip until it turns red. Click a new location for the curve to pass through. Notice that the curves and tangents remain tangent to each other, but both endpoints move along the tangents. Click the radius grip, which is this arrow right here. Go ahead and experiment by moving it. Notice that this grip affects only the curve radius and constrained to the direction of the radius change. Next, select either an endpoint grip or the PI grip. I'm going to select the PI grip. Experiment with reshaping the curve in different ways. Let's grip edit a floating curve entity. Pan around to this area within circles D, E, and F. Fit them in my screen just like so. Select the alignment, and then select the grip within circle D. Notice how it turns red. Now notice that there's a pass-through point, which is kind of a circular grip right in the center of circle F. And notice that it doesn't move. It stays right in the center of circle F. Go ahead and click any location. Now, select this pass-through point within circle E. See how it turns red? Click a new location for the grip. Notice that the pass-through point within circle D doesn't move. Select a new location. The spiral curve entity in circle D moves along the preceding tangent to accommodate the new pass-through point. In the Labels and Tables panel, click the drop-down for Add Labels. Then select Single Segment. Click the curve within circle D. A label is placed on the curve. Press Enter to end the label command. Click the curve to activate the grips, and edit the curve using the pass-through point. I'm going to select this location right here and escape to deselect the alignment. Now the label shows the new length of the curve. So that's how you go about grip editing and alignment in Civil 3D. In this exercise, you'll hide a portion of an alignment from view. When you apply a mask to a portion of an alignment, the alignment sub-entities, labels, and marker points are not drawn, but these items still exist, but are hidden from view. This feature is useful for working on an intersection. In many cases, you don't need to see the alignment geometry that passes through the intersection. In this exercise, you'll mask the portion of an offset alignment that passes through an intersection. This exercise continues from grip editing and alignment. Go ahead and open up your Align-5 drawing, which is located in your Tutorials folder. You'll see that the drawing contains a four-way intersection. Notice that the offset alignments along road A are not displayed in the intersection area. Each of these alignments has a mask applied to the region that passes through the intersection. In the following steps, you'll apply a mask to the offset alignments along road B. Select the offset alignment on the north side of road B. Then, within the Offset Alignments tab, go into Alignment Properties. In the Alignment Properties tab, select Masking. On the Masking tab, click this button right here for Add Masking Region. In the drawing, select the endpoint of the northwest curb. This curb return is going to specify the start point of the masked region. Select the endpoint of the northeast curb return. This is going to specify the endpoint of the masked region. In the Alignment Properties dialog box, go ahead and select Apply. The mask is applied to the specified region. We'll go ahead and do the same thing for the south side of Road B. Select Alignment Properties. In Masking, click this button right here. Select the endpoint of this curb return, and then go to the endpoint of this curb return. Click Apply, then OK. So that's how you go about applying a mask to an alignment in Civil 3D.